My name is Jérôme Beneviste. I studied math, physics, earth sciences in Paris, France, my home country. And I did a PhD specialized in oceanography from space in Toulouse. Most of the instruments we use in remote sensing are common to space exploration and Earth observation, and this is not surprising. What is remote sensing? It's just like, say, you want to know if the fire is hot. You don't need to touch it. You just put your hand in front, and without touching the fire, you feel it's hot. That's remote sensing. If you shine light on an object, your eyes receive the reflection of the light, and you see the shape and the color of the object. That's remote sensing. The sense of touch is much different. You need to touch to feel what you touch, so that's not remote sensing. Using the analogy of the ears and the eyes, we develop instruments that we use both for outer space and Earth remote sensing. And it's based on the electromagnetic radiation, either in the microwave band, like the cell phone frequencies or the microwave oven, or in the visible band, or infrared or ultraviolet. And this is why, if you learn everything about remote sensing, you can study the Earth, the solar system, the galaxies, the universe, and even beyond. Earth observation satellites go around the world in 1 hour and 20 minutes, so it's much faster than an oceanographic ship. It also repeats and repeats, and the observations are made for many years, typically 5 to 10 years. So you can imagine how fast we can acquire knowledge about the ocean, such as sea level, wind, waves, currents, temperature, salinity, thanks to gravity, and also the presence of algae and plankton. The ocean is vast and deep, and by snorkeling or scuba diving, you can take a look at the first 10 to 50 meters. But the ocean is 11,000 meters deep, so it's 1,000 times more. So making soundings from a ship is like launching a rope with a hook from a hot air balloon from above the clouds, and probing to see what you can catch, like vegetation, a bicycle, an old tire, an umbrella, a cow, whatever. But from that, it's really hard to recompose what is exactly at the surface of the Earth. Well, it's the same for the ocean. And if you dive deep, like 500 meters, because of the pressure of the water column, you will need to decompress and on your way back. And that has to be done slowly, and it can take up to 3 weeks. So it takes 3 weeks to come back from 500 meters deep in the ocean, and only 3 days to come back from the moon, which is 800,000 times farther. And, it's 500 times the atmospheric pressure. Well, since the space era, we've been measuring sea level worldwide, globally, and before that, sea level was only measured by tide gauge in ports and just along the continental coast and in the open ocean at islands, but not everywhere in the world. With radar altimetry on satellites, we've been recording that sea level is rising. That's about 3.2 millimeters per year on average in the past 27 years. Well, thanks to the global picture that we can make with satellites, we can see that sea level is not rising everywhere. So this is a regional map of the mean sea level. So the resulting sea level rise on average is creating a much higher flood risk in case of storm surges, and severely impacting the coastal and island communities through damage to coastal infrastructure, the agriculture, and even tourism and recreation activities. The World Ocean Day is taking place annually on 8th of June, and it fosters the public interest in management of the ocean, managing its resources, and keeping us on track with implementing the United Nations Sustainable Development Goals. And so keep an eye on the ocean at least once a year on 8th of June, and of course every day, because the ocean is supporting life on Earth. Once we have mastered the measurement of sea level in the open ocean with radar altimetry, we've put the limit to measure the sea level near the coast, which is more difficult, and in the estuaries, then in the deltas, and we went up in the rivers and lakes. So river discharge is really an important, what we call essential water cycle variable to understand the effects of global change. river discharge monitoring, day by day, is not only for climate, but it's also for predicting floods, which is the most destructive natural catastrophe. In the European Space Agency website at esa.int, you will find almost all the answers for which you have curiosity. And the ones that are not answered are the most fascinating ones, in fact, and we count on you to help answering them. And so have a nice time using space.